It is possible to have distributed air defense rather than having fighter planes concentrated at air bases. This can be done by putting X-wing fighters into tubes. The tubes would be about the same size as a standard cargo container. The tubes would be mounted on trucks. The trucks could be autonomous driving. To raise and lower the tube, cables would be used. Cable near the front, cable near the back, which would raise and lower the tube, and a platform on which the tube would be mounted. You might have hydraulic cylinders to work as buffers, so there isn't an abrupt stop when the tube is raised or lowered. The X-wing fighter would be launched using booster rockets. The tube would be elevated into the vertical position. Doors at the front end could be opened. The back end could be closed with a plastic panel. When the rocket motors fire, the plastic would be blown out, and the X-wing fighter would take off. Some consideration has to be given to the fact that when the booster rockets are fired, there is some danger of them starting bush fires and brush fires. As the rocket motors accelerate the X-wing fighter, air is forced down through the turbine engine. That causes the turbine engine to start turning. It would be a good idea to have a propane tank with maybe 20 pounds of propane. That should be enough for about 1 minute of horizontal flight under cruising conditions. The propane, being a gas, doesn't have to be vaporized. Therefore, it will ignite and burn smoothly, and it will be used to spin up the engine at higher RPMs, which causes the air coming in to be compressed and heated adiabatically. So now when you spray the kerosene in, it will vaporize and ignite more smoothly. When the booster rockets have burned out, they would be separated. It would probably be a bad idea to just have them drop to the ground because they might kill someone. So you probably would want to have some kind of nose cone which would separate and a parachute open just to slow down their descent so they're less likely to do damage when they strike the ground. The X-wing fighter might have 10,000 pounds of weight for air-to-air combat. You might want to have more fuel than that, maybe an additional 2,000 pounds, to allow for the startup, climb, and transfer to the intercept position. That would be about 12,000 pounds for the interceptor at launch. The rocket motors would probably weigh over 2,000 pounds. So let's say the whole weight is about 15,000 pounds at launch. If you have the rocket motors producing twice the thrust of the weight, that would require 30,000 pounds. That would enable at least 1 G of acceleration. If they burn for 15 seconds, you get up to about 480 feet per second, which is over 300 miles per hour, which should enable the X-wing to fly horizontally. And that would happen at an altitude of about 3,600 feet. After the rocket motors burn out, the X-wing would turn over and fly horizontally. Hopefully the engine at that point would be producing enough thrust. If not, it would lose a little bit of altitude while the engine is spun up to speed. When the engine comes up to speed, the afterburners can be lit, the X-wing can climb to altitude, and can fly to its intercept position. If it's flying at 1,200 miles per hour, which is something under Mach 2 at altitude, if you wanted to fly 150 miles for intercept, that'd be 1/8 of an hour. 10,000 pounds of thrust in a standard military engine would be about 6,700 pounds of dry thrust, which is the thrust of the turbine, and then the other 3,300 pounds would be afterburner. Afterburners are horrendously inefficient. The entire fuel burn per hour would be 14 to 15,000 pounds. For 1/8 of an hour, that'll be over 1,800 pounds, plus fuel for startup and climb out. So you need over 2,000 pounds of fuel. That's where the additional 2,000 pounds of fuel comes in. At 30,000 pounds of thrust, the specific impulse for a solid propellant rocket is 220 or 230. The specific impulse is pounds of thrust times seconds of thrust divided by pounds of fuel. So you divide 30,000 by 220, you get about 140 times 15 seconds is about 2,000 pounds, plus the weight for the tube, the nozzles, the nose cone, the parachute. So you get about 3,000 pounds. And so the overall weight of about 15,000 pounds would probably be about right. Solid propellant is moderately expensive. It's certainly much more expensive than kerosene fuel. So the cost of each flight would be fairly high. The X-wing aircraft would have perhaps 2 air-to-air missiles. Air-to-air missiles weigh about 250 pounds each. It could also have a cannon. There was a cannon built in Germany originally by Mauser and now by Rheinmetall. It is a 2-barrel, 27-millimeter cannon, and it weighs about 240 pounds without ammunition. There's also a French cannon, the GAT-30. That is a 30-millimeter single-barrel cannon, which is used in the Rafale fighter, and that version weighs about 150 pounds without ammunition. When the X-wing arrives at the intercept position, it has to have enough fuel for the intercept, but also to fly to a recovery area. 2 ways of recovering it is, one, to have a fixed wing aircraft, which can fly along and lower an arm which interconnects with the X-wing, and then the entire assembly is landed. That can be either a manned or an unmanned aircraft. Other option would be to build something like the V-22 Osprey tilt rotor aircraft. The tilt rotor would have a similar function. It would fly along, it would lower an arm, it would interconnect with the X-wing fighter. The tilt rotor would then fly to an area and lower the X-wing fighter onto some kind of cart or vehicle, which would enable the X-wing fighter to be moved for maintenance and service. An Osprey weighs over 60,000 pounds. The X-wing weighs 10,000 pounds. The tilt rotor would be over half the total weight, so that would be over 20,000 pounds. And you could probably do about a total of about a 40,000 pound overall vehicle weight. The difference in weight would be fuel. That would give you a width from rotor tip to rotor tip of probably something a little under 100 feet, which means it could operate off of an area 200 by 200 feet to allow for some clearance. You would also need shops and buildings for maintenance and service of both the X-wing and the tilt rotor. So the entire operation could be done in an area of about 200 by 400 feet, which is about the size of a soccer field or an American football field. The trucks carrying the tubes with the X-wings could be placed in random positions and then could be launched for intercept. That means that they're rising up from areas where people may not expect them. The X-wing fighter would have high maneuverability, potentially as high as 12 to 15 Gs. The advantage of the X-wing over just a missile is it has larger search systems. Its radar, its infrared systems are larger and more effective and efficient at searching an area for a target. If its missiles aren't used, they are available for use in the future.